For decades, testing intelligence looked like this: an examiner with a stopwatch, timing an examinee's ability to manipulate physical blocks and verbally articulate complex answers. But the actual operational target of these tests isn't the ability to stack blocks or define vocabulary words. Psychometrically, the goal is to isolate Spearman's G, the general mental capacity and fluid intelligence driving a person's performance across cognitive tasks, independent of specific skills. This creates a structural problem. Traditional cognitive assessments like the Wechsler intelligence scales require the examinee to read, listen, and speak. They act as a heavy linguistic and motor filter. This requirement to read, listen, and speak corrupts the data when assessing individuals with communication disorders or limited English proficiency. The filter blocks the signal. The test ends up measuring their linguistic or motor limitations rather than their actual fluid intelligence. The Test of Nonverbal Intelligence, 4th edition, or TONI-4, was engineered specifically to bypass this sensory filter. Standard intelligence tests inherently penalize nonverbal populations. Measuring true cognitive capacity in these groups requires a completely independent testing framework. To achieve pure measurement, the TONI-4 removes language entirely. The test requires absolutely no reading, writing, speaking, or listening on the part of the examinee. Instead of verbalizing answers or manipulating objects, the subject merely points, nods, or even blinks to indicate their chosen response. The administrator records the choice, bypassing traditional motor skill requirements entirely. This format allows the instrument to evaluate a massive demographic spectrum, standardizing results for ages ranging from precisely 6 years and 0 months all the way through 89 years and 11 months. This makes it an ideal assessment tool for populations that are traditionally difficult to test. That includes individuals with autism, those recovering from a stroke or traumatic head injury, or patients with varying degrees of intellectual disability. There is one strict physical limitation to the instrument. Because the stimuli are entirely visual, it is not intended for individuals with severe visual impairments. By reducing examinee output to a mere blink or point, the TONI-4 eliminates mechanical friction. The resulting score reflects mental agility rather than physical capability. The core mechanism of the TONI-4 is a 15-minute progressive matrix format. Test items present visual problem-solving tasks that scale upward in ascending order of difficulty. To maintain consistency without relying on words, every single item in the test is constructed using combinations of strict figural characteristics. Specifically, the test isolates 8 visual variables: shape, position, direction, rotation, contiguity, shading, size, and movement. Relying strictly on this abstract figural content removes mainstream American cultural loading from the assessment. There are no questions about cultural idioms, historical figures, or societal norms. Consequently, a subject's performance on these specific matrices is entirely unaffected by prior information or previous educational exposure. The abstract matrix design ensures that prior knowledge cannot artificially inflate a score, isolating pure deductive reasoning and problem solving. Administering this test requires formal training, primarily to navigate the instrument's specific routing logic. The scoring itself is strictly binary. Every correct response is scored as 1 point, and an incorrect response is scored as 0. This protocol shows how the routing logic works in practice. The examiner must first establish a basal score. This is defined as the highest difficulty level at which an individual achieves 5 consecutive correct responses, denoted by the solid block of ones. Establishing this basal level is a mathematical shortcut. It assumes that if a subject can consecutively solve items at this difficulty, they would correctly answer all the easier preceding questions, allowing the examiner to skip them. On the other end of the spectrum is the ceiling rule. The test administration immediately terminates the moment the subject makes 3 errors out of 5 consecutive responses. This dual bracket system creates a tightly defined testing window. The examinee isn't forced to slog through questions that are overwhelmingly easy or impossibly difficult, which keeps the total duration relatively short compared to comprehensive cognitive batteries. The basal and ceiling algorithms prevent cognitive fatigue and examiner bias, locking the assessment into a statistically rigorous, highly efficient window. Once the ceiling is reached and the session terminates, The examiner calculates the raw binary responses to generate the primary output metric, the index score. This index score is standardized. It is anchored by a statistical mean of 100 with a standard deviation of 15. This chart shows the descriptive terms table provided in the manual. Clinicians use this to translate those numerical index scores into qualitative ratings for reporting, ranging from an average score between 90 and 110 up to a very superior rating for scores over 130. Alongside these descriptive ratings, the manual provides secondary conversions, including percentiles and age equivalents, to give the practitioner broader clinical context. By converting raw binary responses into standardized index scores, the TONI-4 provides a mathematically sound equivalent to traditional IQ metrics without the linguistic baggage. To ground those statistics, the TONI-4 relies on a robust normative sample. The standardization data was collected from 2,272 participants across 31 U.S. states, proportionally stratified by age, race, gender, and socioeconomic status. However, there is a key nuance in this standardization. While the test itself is language-free, English verbal instructions were still used for 77% of this normative sample during the data collection phase. The instrument also has specific statistical reliability limitations. The sample size used to determine test-retest reliability and alternate form validity is relatively small, testing only 63 individuals. Additionally, there is a systemic weakness regarding inter-scorer agreement. The scores used in the validation studies were not independent, introducing potential variables into the reliability of the scoring mechanics. While the TONI-4 rests on a robust national demographic model, clinicians must account for these specific reliability margins when making hard diagnostic conclusions. Despite these tolerances, the concurrent validity of the instrument is proven. It has been successfully measured against similar tests, including the TONI-2 and its own predecessor, the TONI-3. Its primary clinical utility is as an alternative to verbal intelligence tests when those instruments are unsuitable for a specific examinee. Practitioners deploy the TONI-4 specifically to diagnose intellectual impairments in individuals whose performance would otherwise be confounded by language, physical impairments, or unfamiliarity with mainstream culture. These pure intelligence metrics are critical. They are often the required data points for legally and medically verifying referrals for special services and developmental therapies. As a specialized instrument, the TONI-4 identifies intellectual capacity in clinical populations, where traditional batteries encounter significant linguistic or motor interference.